Alright, CNT120, Chapter 4. We're in the last little chunk here with some troubleshooting tools. Now these are actually some commands. Some of these are commands we've used before. Some are going to be ones we're going to use in lab now. So we'll just give you a little intro here, and as you do them in the lab, they'll hopefully make a little more sense to you. First one they mentioned is netstat. This displays any TCP/IP statistics, and there's a whole bunch of different switches you can use, extensions if you will, to get specific details that you might want to have. The kinds of connections, the kind of statistics moving in and out, etc. And actually here's a whole bunch of them in there. So if I just do netstat in general, it kind of gives me everything, but I could dial into, well, I want to know the IP addresses and ports that happen to be current on my system. So if I pull my command prompt up here and do netstat, I think -n was the one that here shows all of our current connections, IP addresses, and ports. This will show me any current connections in here. Well, I see a lot of loop back there, but if I go up here to the top, here should be on my IP and the ports and what they're connected to outside of my network. And you see some of these are waiting, some of these are closed. This could give me an idea of what kinds of things are communicating from my system out. This could be handy to see what is my system communicating with. This could be handy on a server knowing what ports are open, what things are being communicated. If I come out here, maybe I'll even open up another. Oh my goodness. We'll open up the Formula1.com website and let a couple things run in the background. Why not? And those are running in the background, so now all these little things are probably going to be updating and communicating and so forth. So if I go back here and repeat this, I might actually see some more connections show up. And I do. I see a lot more connections show up now than I had before. So these might be some things I'm paying attention to. What is it communicating with? What ports is it using? I see a lot of 443s, 80s. Well, if I start seeing some odd ports showing up here, that might be something I want to start looking into, especially if I am trying to secure some stuff on my network. So let's go back here. There's my netstat, and you see there's other options you can use here to look for and display specific information. Traceroute. This is a great utility. This is going to show me the path that data is taking. So if I know, again, I keep using the hack as an example, but if I'm managing hack's network and I know the data moving from Harrisburg to Lancaster goes through these 4 or 5 steps, if I know that's normal and I test it again now and that changes, well, data might be routed a different way, okay, but if it changes where data stops moving at a certain point, that's a clue as to maybe that's where the problem is or where I want to start troubleshooting. So traceroute actually works by, it's actually kind of sneaky. It works by setting the TTL to 1, and when it hits the first router and that decreases to 0, it sends an error message back. And the sender's like, all right, thanks a lot. Then it sends it out with a TTL of 2, so it gets this router than this one. This one is like, oh, okay, your TTL expired, and it sends another note back. And I'm like, okay, thanks a lot. And it keeps repeating that till it gets to its destination. So if I do a trace, let's go over here. We're going to do a trace RT to, again, I'll pick on Google.com here. This will be quite a few steps, but it's going to go kind of slow because it literally needs to get to the first one, error out, send a message back. Get 2 down the road, error, send a message back. Get 3 down the road, and have an error and send the error back to me. But what I'm learning now is each step along the way. Now, you and I sitting at home, a lot of these would be kind of meaningless to us, but if I'm managing the network and I know what these should be, this starts giving me a clue as like, hey, maybe this is where the problem is. Now, if I start getting timeouts, that might not indicate a fault. It might just indicate that there was too much delay there, or that's a device that's programmed not to respond to these messages. So again, I do need to factor a bigger picture here, but if I know the path something should take, and I get part way and it stops, then I know maybe where I start doing some troubleshooting. And that's what I'm seeing here. It's working its way out there. And if I get to a certain point and it stops, maybe that's where I start my troubleshooting. That's where this comes in handy. That's where it comes in handy. If I'm on a Windows machine, I'm going to use trace RT. If I'm on a Linux or Apple machine, I'm going to use trace route. Last but not least in here, there's a command called TCP dump. This runs on a Linux or Unix system. This is basically a command line packet sniffer. It's basically a command line version of Wireshark that we were using previously. It actually shows these packets in your command line, like I have here. And I can put filters in there. I can put some extensions in there that I'm showing certain traffic or certain protocols, and it'll give me those results. It's kind of handy. It's kind of neat. So if you have a Linux machine, that's something you could try. Here is kind of a summary of a whole bunch of commands we've used previously, and even ones now. If we look back to ARP that we did earlier, we can see the MAC to IP address mapping. Dig and NSLOOKUP we used back in Chapter 3. This helps us query DNS servers for domain names, IP and domain name mappings. IP config and ifconfig we've used a ton for looking up IP addressing information. Netstat we just used to show some network statistics, and there's lots of switches or extensions you use there to get some details or specific details. Nmap for mapping your network, actually hitting a resource like a firewall or a server to know, is there anything open, and if there is that a vulnerability, is it not? Ping for testing if there is a connection to, do we have a complete path or a connection to? SSH and Telnet for remote access. Obviously SSH is preferred because of encryption. Telnet's kind of the old school because it's clear text. TCP dump for my command line Wireshark, if you will, and then traceroute or traceRT and traceroute for showing a path from a source to destination, and that might help me narrow down where the problem is or where I want to start troubleshooting if we have lost connection. And out here they talk about a duplicate MAC address. There is a security risk of spoofing MAC addresses. With that, you can actually program switches to identify that and actually shut that down. You can actually program a switch to do that if you see a duplicate MAC address show up. And there's our ping and trace as well. But I like this summary page here, kind of bringing all these commands to front. By the end of Chapter 4 Lab, you will have done pretty much all of these at some point or another. So keep those in mind. And there is Chapter 4.